Welcome to this video lecture on the cost of capital. The cost of capital is a highly tested part of the financial management exam. This cost of capital, to understand it, you have to realize that those who provide the capital are taking a risk, and those who want to borrow have to compensate those who are providing the capital. And this cost of capital is also used in many aspects and tested in different areas of the syllabus, such as when you are computing the net present value of a project. So in this lesson, we're going to discuss how to assess how much a company has to pay its providers of finance in order to keep them satisfied. The main principle is that the higher the risk faced by the investor, the higher the return they will expect to be paid. So there is a risk and return relationship between the providers of finance and those who need to borrow the finance, who will need to access the capital for their investments. So, because of this risk, we have a theory, the pecking order theory, which gives us the creditor hierarchy. In the creditor hierarchy, this guides in the event of a company being unable to pay its debts or a company going into liquidation. The pecking order theory gives an order in which a company should repay its creditors and investors. The first in the hierarchy to be paid are those creditors with a fixed charge. The creditors with a fixed charge are those who have a caveat or they have a surety on a particular asset of the company. So these have to be paid first so that the caveat on that particular asset is released to enable the company or the liquidators to be able to dispose of that particular asset, to generate the funds to pay out in a liquidation. The second in the hierarchy are the creditors with a floating charge. These are the creditors who do not have a particular fixed charge on the asset, but their charge floats from asset to asset. The third are the unsecured creditors, followed by the preference creditors, and lastly, the ordinary shareholders. So what's the implication of these terminologies? This implies that the cheapest finance is debt, especially if it is secured, since the risk for the secured creditors is lessened by the security in the particular asset. So the cost of debt is denoted by the symbol KD. So that's the symbol that we'll be using throughout the study when we are referring to cost of debt. And the most expensive finance will be equity or ordinary shares, because in the hierarchy, as you can see in the hierarchy, they are the last ones to receive any compensation should there be any funds remaining after paying the other creditors. So the ordinary shareholders, they are exposed to higher risks, hence the cost of equity, which we're going to symbolize with KE or RE throughout this study, is the most expensive finance. So we are going to look at now how this costs of capital is computed. To understand the cost of capital, you have to understand that capital is a combination of equity and debt. So since each one of them has got a is different in the hierarchy, so each cost has to be computed separately. So we'll start with the cost of equity. The cost of equity has got two formulas for computing the cost of equity. The first one is a dividend growth model. With the dividend growth model, shareholders often expect a dividend to be paid at the end of the year, and for that dividend to grow in the future. So by looking at how much shareholders are prepared to pay for this share, which is denoted by PO, it is possible to estimate the return that they find acceptable. So to compute this return acceptable by the equity providers, we can use the first formula, which is the dividend growth model, which is RE equals DO, open brackets 1 plus G, G standing for growth, close brackets, divided by PO. Once you've done that computation, then you add G. So if a firm fails to provide this return to the shareholders, then the share price for that firm will fall. Now you have to remember also that the main aim of financial management is to maximize shareholder wealth. So as management, you don't want the share price of your firm to fall, so you need to ensure that this share price is maximized. Let's look at a very simple example of how to apply the dividend growth model in computing the cost of equity. So we have WPP PLC has just paid a dividend of 60 cents and has a market value of 5.50. The dividend growth rate is 8%, and you're required to compute the cost of equity. So substituting in the dividend growth model, we get 19.8%. But take note, you need to equate the units of measure. As you can see, the question has given us 60 cents there as a dividend, but we've been given the market value in dollars. So you need to change the market value in dollars to cents as well, as you apply them in the formula, in the 60 cents there. The percentage, remember, you have to divide by 100. That becomes 0.08. So Make sure you are consistent with these units of measure to avoid any errors in your computation of the cost of equity and other similar calculations that we'll be looking at in the study. Some assumptions of the dividend growth model. It assumes that dividends are paid and the company has a share price. It also assumes that dividend growth can be estimated and is constant. So this assumption could also be asked, not could also be, but are some of the weaknesses of the dividend growth model formula, because then it cannot be used for those companies which do not have a share price. Although one would use a prox, again there are challenges of using a prox because of different the capital structure in those two companies. The risk involved would be different, but otherwise one would use a prox within the similar industry as yourself. Note also that if there is a dividend about to be paid and the share price is cum div, and the share price needs to be adjusted by stripping the dividend out of the share price. Be very careful as you read the question. Watch out for cum div, ex div. All those have got different meanings, and so needs to be treated differently in the computations. The G, which is a growth in the dividends, it can be growth in earnings, has got two formulas. Some questions will give you the G. Some questions you have to estimate the G. Depending on the information that you are given, you can use one of the two formulas. The first one is the historical growth formula, which is given by 1 plus G equals n square root latest dividend divided by earliest dividends. So you have to make G the subject of the formula, so the 1 has to move the other side as a minus, so you have to subtract 1 to come up with your G. N is the number of growth periods. You don't actually count the number of years given in the question, but you count the periods in between the years for you to get your N. You could also rewrite the N to G if you want to get rid of the square root. So your G could also be your growth in the historical growth method could be calculated as G equals open bracket latest dividends divided by earliest dividend close brackets to the power 1 over n minus 1. G equals open brackets latest dividend divided by earliest dividends close brackets to the power 1 over n, then minus 1. If you use this one, simplify the 1 over n before you apply it in the power to make it easy. Sometimes if you don't use the functions on the calculator properly, you may end up getting wrong. So simplify the 1 over n. So for example, if your n is 5, so divide 1 divided by 5. So 1 divided by 5 gives us 0.2, so it becomes to the power 0.2. The second is the Gordon growth formula, which is given by G equals BR, where B is the balance or percentage of profits reinvested, and R is the return on reinvested funds. So when you're given a series of dividends, then you know that you have to compute G, you have to use the historical growth. Usually questions which require you to use the Gordon growth will not give you a series of dividends. They may give you the profits, and you may have to compute the proportion of what has been reinvested after stripping off the dividends. Let us look at this example, which we shall continue with in the second video lecture.